Welcome everyone. My name is Jarrod and I'm the CEO of the Australian Alliance for Energy Productivity, or A2EP as we're well known as. And I'd like to welcome you all to this webinar on the water energy nexus. May I start this webinar by acknowledging the traditional custodians of where I'm living and broadcasting from. That's in the northern suburbs of Sydney. And that is the area of the Diabatic people, and I pay my respects to their elders, past and present. If you'd like to acknowledge the traditional custodians of the lands in which you reside, feel free to do so in the chat. And for those of you who are new to A2EP, we are a non-for-profit organisation funded by members who share our mission to double Australia's energy productivity. Now, in short, we help business pursue a cleaner, more successful future by producing more with less. We explore the world for best practice. We advocate for programs and policy to help increase energy productivity, and we connect people wanting to decarbonise and improve energy productivity. In this webinar format, please add your questions to the Q&A box and then upvote questions that you like, or feel free to have a little chat in the side discussion. Our speakers will be ready to answer any questions after the presentation. We'll try and do those live with a discussion, but if we run out of time, we'll get them to answer those questions as we move on to other speakers. So we'll be sure to address your questions, so feel free to send them through. And for those of you who've been wondering about A2EP, we've been a little bit quiet in the last 6 months with our webinars, but certainly not quite in terms of the work that we've been doing. We've been doing a lot of work on different studies and outreach and working with different research papers. One of those is working on the heat pumps within Australia and the potential to decarbonise Australia, and how many tonnes per annum that could achieve, and that report will hopefully be out in the next few months. We've also been doing a series of research pieces with the Race for 2030 Cooperative Research Centre, and that's been helping them and working with that on the Industry 4.0 solutions for energy productivity and anaerobic digestion being used to produce biogas for transport, electricity and for fuel. So very busy indeed, and for those of you who want to get involved in any of those Race for 2030 discussions, certainly open to welcome you and just let you know what we're doing there. Please reach out. So we have lots of discussions with energy managers and what have you at manufacturing sites, and of course plenty of people have set targets for energy reduction and decarbonisation. And it nearly always comes up that people also have targets for water usage reduction. And we've been hearing that many times over the years. So we thought it's high time that we looked into technologies and we did some exploring of opportunities and what can be done there. And we thought we'd bring this all together for you today to explore 4 different technologies just for today. And if we take an energy productivity approach, of course, we start by defining the end user service that you're trying to do, and whether that be trying to clean a tank or doing some cooling, we say, okay, well, how can that be done more efficiently, or reducing the amount of water that you'll be using in this case today. If you were to take this 5 R's type of hierarchy into, and this is a common way to look at reducing of waste, and this is somewhat how we're going to be guiding our discussion today. And we have 2 cases to look at today, where we're looking at reducing water consumption where it's needed, and that would be from Alfa Laval. We have presentations from Alfa Laval with their technologies to reduce the amount of water being used for cleaning in food and beverage plants. And we've also got a presentation today from Frigel, who can look at replacing your cooling towers, which obviously consume a lot of water, and look at replacing those with other technologies. And then we also have a presentation from ChemClean, who is going to run us through how you can recycle your cleaning chemicals and therefore reduce water and save energy and embodied carbon within the chemicals that you buy as well. However, I hear you say, in terms of how you look at energy productivity, is that the right place to start? No, of course, we always say once you've got that target in place, we really hope you've got the data and the metering and monitoring is in place. And without that, you know, you're really not sure of how you can set those targets and improvements and watch how you're going. And so with that, we thought, what better way to start this presentation other than having Schneider Electric join us here today. And Brad Yager is here, and he's the segment lead from consumer packaged goods within Schneider. And Brad, absolutely a passionate person when it comes to climate change and sustainability. Brad's going to present to us today, and I'll get Brad to start sharing his screen now and bring up that presentation. But Brad works with has been looking at new digital capabilities and partnerships to achieve sustainability within Schneider and their customers, and has a very strong focus on the food and beverage segment within the Pacific region. Brad, really keen to hear about Schneider's approach for reducing water and energy in this crucial step within food and beverage manufacturing. And then over to you, Brad.
Great, thank you, Jarrod, and fantastic. And thank you for the opportunity to talk today about some of my passions. I lead the food and beverage segment for Schneider Electric across Australia and New Zealand. I also have a dual role looking at the water segments in those countries as well. So to be able to talk about three of my passions, food and beverage manufacturing and optimising that, water, and then also sustainability and better use of energy is just a fantastic opportunity. So hopefully I can share some insights from Schneider Electric's perspective today. And pose some questions. So I've got the chat here monitoring, so feel free to pose questions as we go, and I'll leave some time at the end. I'll start by saying there is no alternative to water like there is for energy. It's a finite resource. We must maximise the use of it. And industry and manufacturing specifically requires massive volumes of water from being an ingredient, being used for conversion to steam, driving processes, as well as in cleaning. And it's the cleaning part that I'm going to focus on today with a tool that Schneider has successfully deployed to help better visualize and optimize cleaning processes. I mentioned that water's a big user in manufacturing, and a couple of stats here just to get us the idea how big the prize here if we want to actually be more efficient with our water use and then have the subsequent energy efficiency on the back of that. It takes about 25,000 litres of water to grow and produce a day supply of food of a family. So that's when you sit down and have your meals with your family for a day, and you use water yourself as part of that, but there's a whole bunch of extra water that's been used in that whole supply chain to deliver that meal onto the plate in front of you. And in fact, just the 5 biggest food and beverage manufacturers, we estimate, uses about 600 billion litres over a year in producing that food, some of that food and beverage. Which equates to the daily water demand of all people across the whole planet. So just 5 big manufacturers, and they're big manufacturers covering many countries, but just them alone is the equivalent of what we use for people for our daily water. So a great opportunity. It gives, if we can just make a small dent and be more efficient in our water use in this pace, we can make a big difference. If we look at where we can start to make a difference in that manufacturing process, if you take out the core ingredient part, which is unlikely to be able to be removed, then about 60% of the non-product water is used within cleaning, and specifically cleaning in place and heat exchangers within that process. So it's a great idea, great place to start. Sometimes because we're dealing with product quality and consumer safety, we work on time-based, and we can go through over rinsing, over cleaning, which results in excessive water and excessive chemicals. This is an inefficient and insufficient, I would say, process. They take too long, they're indefensible. They don't provide a comprehensive view of actually delivering that safety. It's an over-engineered solution. And this is where data can be the key, to Jarrod's point before. If we can start measuring and obtaining additional data and then visualizing that data in a contextualized and meaningful way, we can achieve 2 things. We can optimize and be very confident that we're delivering that quality and safety, but it also means that we're being smarter use of our water, chemical and energy, and we reduce that as well, which is the water energy nexus. So where do we start in this process? Where are the opportunities? Well, we can reduce the operating time and therefore the wastes if we do optimize. which is the core thing we're going to talk about today. It means we're getting better visibility of what we need to do. We're doing enough to deliver what we need in quality and safety perspective and not delivering over that. And also we're picking up errors or mistakes very quickly and being able to react faster to deliver any wastage. There's additional benefits with this type of approach. We actually get better traceability and we're moving to a more future quality state. So we're in addition to the savings here, we're actually getting better quality, better data, and able to make better decisions holistically as a business. So that's an added benefit, despite just the cost, energy, and savings in reducing water and energy. And overall, that delivers us a lower carbon footprint, of course, over time. We know we optimise, and as we want to produce new lines or change processes, we have the data to be able to make informed decisions and optimise our approach going forward. So it seems like a no-brainer. How do I get started, I hear you ask? Well, I'm glad you asked, because that's my very next slide. It's a simple, stepwise and scalable approach. The tools are there. It's just a matter of getting started, or if you've already started, using the tools that are there to start providing services for those optimization opportunities. Simply, every time, start with a basic walkthrough audit. Understand someone that's familiar, ideally, with your process or similar process, that can walk through and start to identify areas of opportunity. And then also, as part of that walkthrough, we're highlighting areas where perhaps we see opportunity, but we need additional metering in order to make sure that we can measure. If we can't measure it, we can't control it. Then we can make some, then sometimes, and in fact, I would say oftentimes, there's a quick win just with some basic changes in how we're actually managing our cleaning processes today. But in order to go further, in order to benchmark those improvements and to also find additional improvements, then we recommend installing some optimization software. We then collect every piece of information we need to document evidence of proper cleaning and causes of waste and excessive use. That then allows us to do some advanced analysis. And then once we do that within an individual line or an individual plant, we then expand across multiple sites, and then we can scale. We then have a platform to actually benchmark plant to plant. Pretty simple model on how that actually looks on the left there. We need that real-time data collection. Oftentimes that will already be sitting there within your control or SCADA systems today. It's just a matter of making sure we identify what's already there, and if there's gaps, we can add some additional metering. We then bring that up. We understand what the key, and we need to build what we call the golden numbers. What's the key? What's best practice look like? Optimal cleaning processes. And we build those parameters. We can, in addition, and we would recommend at the same time, although it is optional because it's not directly impacting of the cleaning process, but adding an energy management piece as well. By doing that, we can directly connect what changes we make into our cleaning processes and measure the direct impact on our wages, our water and energy use. So highly recommended to do that at the same time. We then bring that up to that visualization dashboard, and I've got some examples in a second of what that might look like, which makes it very easy to quickly identify where we're doing really well, which is what we hope to see most of the time, or where there's a gap and we're not running it in an optimal way, and then suggest areas to deep dive and investigate to improve. So we get some really, really fast upfront stepwise improvements once we've documented what best in class looks like, and then we continue to make sure we maintain that with the regular use of this dashboard, and we directly link that to the energy and water savings through that energy management piece. None of this works without a level of services, so we need to visualize the dashboards, but also we need to continue to do that. And the solutions, they're already there available, and happy to have conversations outside this about how quickly and easy it is to get started. Agnostic to control system or product or meters. This is simply sitting over the top. It's easy to add on and deliver some immediate success. Modular, start small, scale fast. Once you see the benefits, it won't stop you. Just some examples of what the dashboarding might look like. Up on the top left, you can see the dark yellow line there. That's what an optimal cleaning cycle that we determine would look like. And then you have immediately behind that, and you can delve into each of the various, the 5 T's that we're measuring there to work out where we're operating behind optimum. You can see on the left we're relatively close, although we've started early. So that's a wastage piece there. And on the right, we started at the right time, but not exactly the same, and we've gone long. An additional way of viewing that same information is on the right, is on that top square, but in the spider graphs, where you can start to see in a different, easy to identify, visualized way where there's a gap. That inside shape should match the outside shape. The outside shape is optimum, the inside shape is not. So we immediately see a gap. The one on the document on the right, screenshot on the right, is similar information, but now we're looking at line by line in a more tabular way. So some people prefer the visual, some people prefer the tabular. We're getting the same level of information, measuring against those golden KPIs. We just need to act on the red. If there's no color, we're all good. And on the bottom left, that's an example of that LinkedIn energy management dashboard, which we can immediately see exactly the impact that our improvements are making. So just some examples. There's full-blown demos that we could run with more time to deep dive into what that looks like and get a real feel for how easy this is to identify opportunities. And then once we've done that at a single site, then we have additional dashboards that can be used. And this is an example that actually we're now benchmarking site to site. So you can almost gamify the process and actually say, well, this particular plant is running optimal at a high percentage rate to another plant. What are they doing well? They can start sharing best in class, and we get people actually striving to do more. I believe it makes sense just from the start by saving water and therefore saving energy, but it also makes great cost sense as well by installing a simple solution and some services here. Here's some examples, and apologies that it's in euros, but these are from my French colleagues for some real deployments that were done throughout Europe, where you can see, and the cost savings are across multiple areas. It's the water reduction, it's the energy reduction, but that then results in less actual treatment of water and then also chemical usage. So a return on investment typically much less than 2 years, plus all those additional benefits that I indicated at the start. We're increasing the productivity, we're not wasting time, we're improving traceability and ensuring quality and safety. Just some example case studies. Unfortunately, this is a place in a factory in France. I can't use the name in this particular example, but over 160 references. They're producing 50,000 tonnes of finished dairy. It's a dairy plant using about 40 gigawatts a year. They wanted specifically in this instance to lower their energy costs. They implemented this optimization visualization solution, and they achieved that with a payback less than 2 years. So a real world example where they had a stated ambition and they were able to implement it. And what they loved was that was simple to implement and became a secure investment over that time using the Schneider EcoStruxure Clean in Place Advisor, which is just one of a Schneider tool that can deliver some of those benefits that we've been talking about today. And they went through that normal process that we talked about: a walkthrough audit, some energy performance contracting. Another example, in fact, the world's largest bottled water company making the Perrier sparkling water. Similar scenario. They wanted, in addition to the energy or cost savings, they also wanted the improved traceability in this example. And you can see some of the stats on what they've demonstrated there. I think I'm coming up to time. So I'll move to my final slide that say, although there's some specific examples, and in fact, we can actually talk directly to, and we've got some videos giving some more deeper dive on the Nestle example if you go to the Schneider Electric website. But here's just some example of other customers that Schneider has already directly worked with that have achieved benefits by doing a CIP optimization strategy, reducing water, reducing energy, and also, more importantly, reducing cost. Or perhaps not more importantly, I should say. So if you want to get started, please reach out. Happy to have a look at the chat. What have we got in the chat here now? If we've got time, Jarrod.
Absolutely. Let's see if some questions come through. Just type them into that Q&A box, and we'll have a look at those. We've got. I'll take the first one here, actually, from Ian Olmsted. Was the powder plant able to achieve their target of 10% energy reduction, or was it just that the projects implemented had sub 2-year paybacks, which is also good?
In those examples, both, yes. So the 10% reduction was justified on the back of the 2-year payback. So to achieve one, they achieved the other. I don't unfortunately have the exact saving there, but it was buried. If you looked in that previous slide where I talked about the specific kilo, euro, dollar amount. But so yes, both. That's the answer.
Brilliant. Thanks, Brett. Yeah, and so some more questions come through, but while we're waiting for that, Brad, we often hear about the problem of getting funds allocated towards this sort of project, because when in a traditional cost benefit analysis, you know, it says, okay, what's the return on investment for this? You're like, well, I don't know until I do it. And then it's a little bit of the old chicken and the egg thing going on there. You mentioned there, start small, scale fast.
Mm-hmm.
Is that the way to get this started? And you know, what sort of dollars are we talking about to get this started, do you think?
Yeah, we're only in the thousands of dollars from a software perspective. The costs are in the associated services, and often that might be able to be associated with some sort of interaction that you're already having. So I think in this case, and I've been in that, I've been stuck in that pilot purgatory type scenario before, where it's hard to get the business case up. This one just makes sense. There's lots of it outside of a public forum. There's lots of examples where we can reference and have conversations with other people that have gone through the process. And then the traditional business case approach, actually, from my perspective, does make sense in this scenario. But you can still start small for a single line, and then that will give you your own confidence for your own business that it's easy to scale throughout your business. But there's certainly lots of people that have gone through this. This isn't cutting edge. It's technology. This is more traditional. Easy way to get started.
Yeah, good one. So yeah, plenty of references there to give confidence. So that's good to know. Very good. Question from Gary Rosengarten. Do you find the industrial sites are instrumented sufficiently, or do you have to factor in instrumenting them to get the data?
Because we're dealing with something that's impacting safety and quality, typically there's already enough to get some added the immediate benefits. It might be if you're going, once you've got the early quick wins, it might be there's an opportunity to add some additional metering to add additional benefit. But I would say in most cases you get the benefit with existing metering that would already be there from operational purposes within the control systems.
Yep. Because they're often checking just how much, what that flow rate of that CIP is, and there's a lot of tests around that and the temperature and things like that already.
Exactly. The only place you wouldn't have that if you're running on very manual systems that was relying on humans, and then in which case step one would be to do a level of automation first anyway, and then the automation would require the metering. So really you need a level of automation to deliver the benefits.
Hopefully not too many swing bends and more valve manifolds, and good. Yeah. And look, we see that definitely, that problem with a lack of instrumentation or sub-metering, definitely when it comes to natural gas usage and electrical usage. But you know, water usually, you know, hopefully okay in this case. So that's good. Very good. We'll see if another one comes in, but just another one I've got then for you, Brad. You mentioned you had IoT, Internet of Things there, and mentioned in one of your slides, and we certainly see the cost of that is coming down for that connectivity. How have you seen that impacted this offering in the CIP Advisor?
Well, it sits for us because it's a bit of software that can be applied over the top of existing systems. It sits for us in that IoT or industrial IoT type space because it's a sort of physical system that can sit across an existing system. It doesn't have to directly impact the business, and I think that just makes it's probably people looking for those additional analytics that they can apply on the back of IoT take up that makes this type of solution more appealing and more accessible. It was always there, but perhaps, don't tell me how to do something differently. I think what IoT has brought is an openness to try different things. Or to use a level of analytics to optimize, and that's really what we're talking about here. So you would have seen there's lots of different smarts that sit behind those dashboards that are actually trying to identify normal trends, optimal trends, and detect variations, and which is I would say advanced IoT. In that it's not just a matter of getting more data from more places, which some people view as the IoT, but it's that advanced analytics that IoT can bring. And once you've got that type of platform, it can actually, and in fact, the way we do it at Schneider is the clean in place advisor solution can sit into our broader platform, which is our Plan Advisor. So it ends up being one window where you look for your clean in place, but then it becomes a seamless way to add in additional, so it might be your energy monitoring, then it might be predictive maintenance, or other modules can then plug in. So it's a way to start on that IoT journey as well. It's something that makes sense in its own right. But by putting this in place, you're actually starting to build a platform to add additional analytical type solutions.
Brad, thank you so much. That was great. And if there's any more questions, feel free to throw them out there, and Brad can answer them in the chat box as we move on. There is the comment there from Abhijit from RMIT about wastewater using a lot of energy, and I think that's going to come out here, and it comes out in yours, Brad. You're reducing wastewater as you optimize this, and then we'll see that coming out in the next few presentations as well. How do we reduce that wastewater? Very good. Thank you, Brad. Let's move on now, and we've now got a presentation from Alfa Laval. I'd like to welcome Morton, Eckhoff and Marwan Baig from Alfa Laval. Morton is based in Denmark, and he's been working with Alfa Laval for some 5 years for their hygienic fluid handling division, and Morton is their specialist for tank cleaning, and it works with general day-to-day technical support for that entire tank cleaning portfolio that they have. He's joined by their local food and beverage manager for Alfa Laval, Marwan Baig. Morton, if I could get you to share your screen and start presenting, that would be fantastic. But between Morton and Marwan, we'll get a good feel for reducing with cleaning equipment, and also optimizing the way you clean the valves as well. Morton, that's coming through. I'll get you to put that in a presentation mode, and away we go.
Yep.
Over to you. Thanks, Morton.
Yeah. Well, yeah. Thank you. As mentioned, I work with technical support for our tank cleaning technology, and we have some different solutions to help optimize and save water in doing tank cleaning. When we look at tank cleaning in general, one of the most important aspects is something called the inner circle. You can compare it to when you wash your dishes at home, the amount of time, the amount of mechanical effect applied, and the cleaning media used, and the temperature all comes into play when cleaning your dishes or cleaning a tank. If we spread it out to the different technologies, the most commonly used is a static spray ball, which is basically just water in, water out, and it in general takes a lot of time compared directly to the jet head, which you can see on the other end of the screen, is much more impact and mechanical effect on the tank walls, thus reducing the time needed to clean, and also in the end water used. The different technologies we have, as you saw before, is the static spray ball, which is basically just water in, water out. So it uses up a lot of water, and it has a high flow rate. Not only due to the time spent on cleaning the tank. The rotor jet head is basically a spray head with slots instead of holes in it, and a mechanical part. So you have the rotating device spraying much more water on the tank wall, reducing both time and water usage. And then you have the jet head with impact nozzles, increasing the mechanical effect on the tank walls, thus decreasing both time and water spent. The newest addition to the technologies is the wall-mounted nozzle, which is mainly used to clean agitators and other internal components in the tank. The static spray ball cleans in spots on the tank wall and uses the water from that to clean the rest of the tank. It takes a lot of time to clean the tank, and you have to adjust the other factors like temperature, sip media, in order to decrease the time. But ultimately, it will always have a high water consumption. For the spray head we have is it cleans with fans of water, so it's much more efficient and much quicker in cleaning the tank. And in general, we say that moving from a spray head spray ball solution to a spray head solution, you immediately save up to 20 to 30% of water. For the rotary jet head, excuse me. For the rotary jet head, it's impact cleaning on the walls, and it cleans in a cross pattern, ensuring the coverage of the tank completely. Due to the efficient nozzle impact, it has a low water consumption, and it is fairly quick in cleaning the tank. And in general, we say that moving from the other technologies to this is another 20% in water cleanings. Water savings, sorry. Some of the arguments we tend to hear when suggesting the other technologies is that they have a high investment cost, and that the current installations needs to be altered, which is why they often tend not to go with these technologies. But when you do the long-term cost benefit of it, as you mentioned, Jarrod, before, that the initial cost benefit is not always looking good for these technologies, but in the long run, the benefits far outweigh the initial cost, because you save a lot of water and you can save energy in terms of with the higher impact you can reduce the temperature, and not only to mention that you can increase the production rate in your production, because you reduce the time spent on cleaning, so you can have more productions running through. We can also reduce product waste, mainly in terms of on-oil coverage on agitators and other internal components, where residues can lead to product needed to be wasted. I also have some stories for you. We have had a case from Singapore, a manufacturer of pharmaceuticals and personal care, such as toothpaste. The mainly goal for them was they wanted to eliminate the need for manual personnel to go into the tank and clean the top connections in the tank, because the current static spray balls couldn't reach that spot. So in the end, they opted to go for a rotary jet head solution in the tanks, and not only did they eliminate the need for the manual cleaning for the manual personnel to clean top connections, they also had a heavy reduction in both water and energy consumption because of the reduced cleaning time. Another case is Joseph Vaught Brewing in the United Kingdom. Their main case was that they wanted high efficiency cleaning for their tanks, and to get the best mechanical pressure on the tank walls, because the static spray ball solution couldn't clean properly. By going to the jet head solution, they had instant water savings in their test tank of 30%. And yeah, going forward, they also saw that they reduced energy savings because they could clean the tanks much quicker. And when we implemented the new wall-mounted cleaning head, we had a case with a large Scandinavian dairy who was going to have new tanks implemented on the site, and the task for these new tanks was to ensure 100% cleaning coverage. So we went ahead with a jet head solution and the wall-mounted cleaning solution to efficiently clean the agitators in the tanks, and we ensured the 100% cleaning coverage, but as a big bonus, they saved up to 80% in water savings and cleaning media for the SIP cycle, and they had a high reduction in the energy consumption for the existing tanks when they switched to this solution, and it actually contributed for them to achieve the annual sustainability goals. With that, I will give it over to you, Marwan.
Thank you, Morton. Interesting to see a lot of examples on water savings and efficiency overall. So now I will talk a bit about our control unit, which is used in the process valves for hygienic industry, and how we made it smarter, which has resulted in water savings across many hygienic food, dairy, and beverage industries. So the next slide, please. So for the people who are not aware, I would say that, of how a mixed flue valve, this is a mixed flue valve which is predominantly used in the hygienic industry. And how it really works, it has two seats and two separate products flow through each upper body and the lower body of the valve. This is the most common valve you will find in large food, dairy and beverage industries, which process a lot of liquids. In the two seats, there are seals which can only be cleaned when we perform a seat lift. Without going into further detail, I can say that each time we are cleaning these valves, we are losing a lot of water since it goes down the drain. And what I can say is that the moment we trigger this signal for a seat clean through a PLC for a valve seat lift, the first half a second, and it depends upon the size of the valve, is a time when the fluid will clean the seal most effectively, as it is a turbulent flow at that time. The time from a PLC to valve is basically has been a bottleneck, as it has been difficult to control. So what we required, this job could be done locally via smart control unit. And with this control unit, we have the ability to do the seat lift of the valve precisely in terms of timing, and which results in huge water savings in water. So if you can go to the next slide, please. So here is a graph which shows that one seat lift of 5 seconds results in 5 liters of water consumption. And then with this feature, which is called the burst clean feature, which is triggered through the smart control unit, it results in less than 1 liter, in fact, half a liter. So bearing in mind that when we are talking about a process, there are multiple seat lifts required for the cleaning of line at a given time. So, if we do the total, let's say on a per year level, and we are talking about millions of liters of water being saved and effectively being used for better cleaning. And I would say this technology has been there already for quite some time. It's been more than 3 years now, and it's been adopted. With a proven track record too. I would say in a lot of large dairies in Europe, and also some in Australia now as well. But then if you can click to the next, there will be a link. There is definitely more information available on this. It is very interesting, and I would encourage. If you can have a look on this, there is an interesting example of a video which also describes this in further more detail, and then where we are demonstrating it on an example for a peanut butter, which is a quite interesting example, I would say. So with that, I'll leave to the next speaker.
Marwan and Morton, many thanks for that. Marwan, maybe you can pop that link, or Morton can pop that link into the chat so people could click on that one easily for them. Very
definitely.
good. Question here from Roger to Morton. The rotary jet head, you've now got introduced some moving parts here. How does that have an impact on the maintenance costs for it? And can you maybe give us a quick rundown on how that biannual maintenance for that works?
Yeah, well, it's actually not too bad. We normally recommend a service interval, a maintenance inspection of the unit after approximately 300 hours of running time, where you simply take it down, look inside it, and verify that the internal gear parts of the jet head is okay, and then you assemble it again, put it up there. And then it can run for another 300 hours. So it's actually not too bad, and it's media lubricated, so it's fairly easy to maintain and
is there like a motor and seals driving this at all, or?
There's a small gear made of PEEK material inside it, which drives the nozzles, jet nozzles of it, and these are media lubricated. So when you run the water and the seed media through it, they will always be lubricated by it. And these are the things that needs replacement after many hours. Usually, I would say 2 or 3 maintenance steps. So the steps of 300 hours, maybe. Yeah, for the second or the third one, some replacements will be needed, but it's a 30-minute job, and then you're good to go again.
But we're not talking about, there's no motor drives here, electrical motors driving this. It's purely driven by the fluid itself, the cleaning fluid.
It's driven by the fluid and the pressure going into it.
Good one. Is this, I've got a question here from Nurali about is this effective for sewage treatment? So maybe it's like cleaning tanks or so, or cleaning pipes and things in sewerage. Has anything been done much on that sort of wastewater side of things, if I understood the question correctly?
No, I actually don't have any experiences with it yet. In general, for the industrial industry, we haven't I haven't the best examples yet. So I think there's a huge potential there.
Very good.
For this technology.
Very good, thank you. And I think that'll do us there. If there's any more questions, please by all means put them in the chat there, and Morton and Marwan can have a little sidebar chat with you there and answer any questions you have. But many thanks for that presentation there, Morton and Marwan.
Thank you.
Okay. Now we're just moving on. So now we've looked at process and how to reduce that in the water consumption and with that energy in the process. We thought now let's have a look at the utilities side of things, and I'd like to welcome Gyula Szekeres, hope I pronounced that correctly, Gyula, and he's the business development manager for heat rejection systems for Frigel, and Gyula's been working in energy efficiency for some 16 years and has been pioneering the adiabatic cooling systems for Frigel, and he's joined today by Roger Ong, who works for Chudleigh Sutch, the local Australian representative for Frigel, and so that between them we'll be able to answer all the questions in terms of service support and product. Gyula, could I ask you to share your screen and take us through these products that will reduce the water consumption for utilities?
Absolutely, thank you. Can you please just tell when it can be seen?
That's coming through beautifully. Thanks, Gyula.
Very good. First of all, thank you, Jarrod. Excellent opportunity. And I started to calculate if you put together what Schneider of Laval we can do. I mean, lots of money to spend on something else. Extremely good. Thank you for the invitation, Jarrod, again. So in terms of us, very shortly, I just want to go through what we are. Frigel, absolute pioneer of adiabatic cooling, 40+ years for sure in this field. Italian company, and very shortly lots of installations. And just to put something into perspective for you, we spared so far at least 15 times the volume of the Prospect Reservoir in Western Sydney parklands. I think that's something you can relate to. So there's a huge amount of water we saved. We are globally present with adiabatic coolers, chillers, and temperature control units. And you can see many factories around. I'll give the word now to Chudleigh Sutch, to Roger.
Okay, hi everyone. Chudleigh Sutch is based in Melbourne. We've been involved with Frigel for over 12 years, and over the period, we have supplied in excess of 100 plus installations in Melbourne, Sydney and Adelaide, and also New Zealand. Our main focus is to provide engineering and turnkey solutions to the customers. Our sales engineering team resides in the newly established facility in the Melbourne Tech Centre, in close proximity to Monash University precinct. We have service teams to service our equipment, Frigel equipment as well, in Melbourne and Sydney. So that's a quick short intro, and I'll pass it on to Gyula again because they've got a lot to talk about the equipment.
Thank you very much, Roger. I think this thing was needed because of, after Schneider and Alfa, Laval, we need a bit of a more introduction on the brand. So we fight climate change as all the other industries represented here are doing. And the good thing that we can also address energy, water, and carbon footprint. Good news is that whatever industry you are in, I mean, maybe not whatever, but nearly all industries can benefit from our solution, no matter if it's a data center, it's engine cooling, it's any kind of power solution, is it biogas, no matter, we do have a solution for that. And these points which we can add to this technology conversion, moving away from the traditional cooling tower towards adiabatic cooling, is like a Lego, addressing efficiency on each step, on the fans, on the design of the coil, on the patented adiabatic chamber, and of course the glue which makes this together is the absolute possible of modulated operation of the unit, the control system, which is providing not only control but also a fantastic surface in terms of understanding what's going on. So that's a brief intro from my side on the benefits, and now I'll give the word to Massimiliano, who is going to go over the unit.
Thank you. So let's speak about diabatic cooling and how it works. Basically, we are speaking about a dry cooler solution, which is the machine, the core of the machine, where we have, let's say, added a technology called the adiabatic chamber. What does it mean? So it means that we are able to adapt or to keep the cooling capacity or the living water temperature out from the machine, the constant temperature, thanks to the fact that we can keep the ambient or the air temperature that is coming in at a constant level. So along the year, from winter time to summertime, the machine is adaptable to perform at the design condition that has been set. What the benefit of that one is that we are able to modulate performance, and in that way we reduce the water consumption, the energy consumption along the year. So we use when it's needed. If we compare the technology again towards the let's say the spray to hybrid, and we compare with the wet cooling or cooling tower, we can see here several references. So take as a reference the cooling tower, what we can do from spray to hybrid configurations that in relation to the ambient temperature, moving from dry to hybrid, we are able to get closer and closer to the wet bulb temperature, which means that the more we use technology moving from left to the right, the more we are close to the temperature, to the wet bulb temperature, which is the typical reference on the cooling tower. As a consequence of that, your footprint will be reduced from dry to wet. Your investment costs get lower. Your power density, which is the heat rejection relation to the footprint, increase from dry to wet. And as a consequence, your energy saving and water saving is getting better and better. Two references are important. So the energy saving is, let's say, moving very much to the, let's say, to a saving money. The more we are using, let's say, adaptable technology, as well as water saving. And last not least, from a hygienic point of view, those kind of technology are, let's say, aerosol free, and the risk of Legionella is out of this consideration, so out of this problematic. If you look at the Diabatic and what also Frigel developed, so we are more talking about hybrid configuration, hybrid pad. So it's a solution that is very much adaptable along the years from dry to hybrid, and it works on the stepwise. In the cold water, in the cold weather, you are, let's say, dry condition, which means that very energy saving and water saving approach. And the more you move to hot summer or to hot season, you start to step into adiabatic mode, and in a very, let's say, extreme condition, extreme hot temperature, you move into an hybrid mode. You can see and you can benefit from what you can see on the right side. You adapt the energy and the water usage very much. So water saving and power saving is a potential, how to say, logic that is adopted by the units in order to perform at the best condition that you require. You want to save more water, you are a little bit consuming more energy. You want to save more energy, you're a bit consuming more water. So it's very much adaptable to the condition that we need to perform. Okay, if Roger want to explain a little bit more on that part.
Okay, thank you. Look, instead of going through all the dot points in there, I think we've supplied a lot of Diabatic coolers to the industry, either as a new site or as a retrofit to replace cooling towers. And most of the common issues that we've seen when we deliver to a cooling tower retrofit is there's a lot of blockages and scaling problems associated with the process, and resulting in loss of flow and poor heat transfer. And consequently, a lot of clients tend to use the cooling tower to run at a much lower temperature, making it using more water and more chemical consumption, not to mention high maintenance costs. And the other issue that we see complaining to us is the cooling tower registration and compliance requirements that has to be attended to regularly here in Australia. And usually it's around about quarterly or 6 months, but it seems that it's going to be increased to a monthly reporting. So the administration cost of cooling tower is going to be quite hard to maintain. What we can see is that in the future, a lot of the smaller companies that do not register the cooling towers, and they do not operate on, let's say, a 24/7 basis, they find it difficult to justify the capital investment to go to adiabatic coolers. So the use of cooling tower is still going to be quite common for the smaller users because they're cheap and they're quick to install. Consequently, it's always harder to approach those clients than to attack the larger customers. The graph, the table on the right-hand side, which you can't quite see in total because the video is covering half of it, tells you the advantages of the cooling tower and how severe the advantages are, and also of the LDK. So read through that, and I think it's pretty obvious. Yeah. Anyway, I wanted to focus more on the next slide, which is the return on investment. Gyula, please. Okay. Firstly, let me look at the graph on the right-hand side, because that is a linear projection of what the cost looks like in future years. And in reality, that is far from the truth, especially when factors such as chemical costs, maintenance, machine downtime are all taken into consideration. Typically, payback is assessed based on 2 to 2.5 years, and that seems to be the accepted benchmark in decision making. And as I said before, it can be very challenging for smaller companies when they do want the technology, but they can't justify the payback periods of 2.5 years. The water consumption has the greatest impact on cost savings when compared to the LDK. The energy has got some contribution to cost savings, but water by far is the largest factor in contributing that. Now, we sold close to 30 megawatts of heat rejection equipment in Australia, and this, contributes about 330,000 cubic meters of water each year, and cumulatively speaking, the users can enjoy up to about $1 million of cost benefits each year as a result of going to dry coolers. Therefore, aiming for short payback period like 2.5 years is often not attainable. I think more emphasis should be put on the life cycle operating costs, which you can see in the graph on the right-hand side, which is significantly higher than the original CapEx investment. So I encourage people to take a longer view in pushing for increased efficiency, which at the end of the day will increase the bottom line of the business. So I think that's one way that we can justify going away from cooling tower and using a diabatic cooler. That's it.
Thank you, Roger. And we want to present a few cases that where adiabatic cooling or adiabatic cooler was the choice. Here we are in the field of waste to energy plant, a plant which is based in the Middle East, where we are required to work on the cooling side of a turbine, lube oil cooling. As an indirect system where the challenge was to let's say, reduce as much as possible the water consumption. So we are Middle East, where, of course, water is not, let's say, given for granted. And the demand to limit this was a high request into the spec. So, as well as the footprint available and a lot of mechanical specification. We are speaking about energy plant. So we designed, or the design that we made with in that respect with the LDK, is that based on let's say an adiabatic time based on ASHRAE database. So we are able to precisely calculate the amount of water needed to be, let's say, used in order to keep the temperature condition required. And this, let's say, came out into a water consumption which is neglectable compared to required water consumption needed with the cooling tower. So we are speaking about almost 99% of saving in water consumption, as well as a 30% saving on energy consumption compared to equivalent cooling tower solution. So which is, let's say, great advantages and turns in operating cost and running cost over, let's say, 80% saving compared to the same technology. So, which is a great example of how to continue and how to, let's say, support the adiabatic or the conversion to adiabatic cooling technology. Another case that we want to share is about heat pump and combining heat and cooling solution. So here, the flexibility of adiabatic cooling is also possible because of an heat pump. We can work on the summer cycle, winter cycle, adapting the function of the adiabatic in that respect. So if we take a summer cycle where the heat pump is working on ambient condition of 35 degrees as example, and we need to, let's say, cool water from 35 to 30. So we generate a heat rejection of 1 megawatt as an example. And here an exactly example of, let's say, heat pump used in a building or in, let's say, commercial premises. So this kind of a solution on a winter cycle turned into reverse mode, and we use the adiabatic cooler as an air cooler. So we are cooling water or heating water and cooling air in that respect. So we are able to keep in the same size of the unit double function. So heating and cooling according to the season temperature. In that aspect, modulating the unit in terms of functioning, so we can go even in a very low temperature winter ambient. So which means that adapting the functionality, we are getting into very cold weather, and we are able to keep the performance of the heating capacity in the same range of performance. All in all, the COP is still a great value, having absorbed a very low power consumption in that respect. So one case that heating and cooling solution on heat pump and using an adiabatic, it give a high flexibility, which is not possible by using cooling tower in that respect. That's it from our side. We would like to thank you for the opportunity, and available for question.
Gyula, Massimiliano, and Roger, many thanks for that presentation. This presentation is being recorded, and we'll have that distributed to everyone who's registered here for next week, so you'll be able to go through that. So don't need to take too many screen dumps and too many notes. You'll have that reference there for you. If you do have some questions, please put them in the chat or the Q&A, and we'll be sure to get to those. I might kick things off a little bit there. Probably a question for Massimiliano. Is the cooling water or water, is that the only medium that can go through one of these units, or can you put a refrigerant straight into there as well?
Normally, we are speaking about water or mixed water, let's say glycol or different, let's say, media. So in that respect, of course, there is also potential to work with a different refrigerant, which we consider on case by case. But let's say, the major use of adiabatic is very much into the water or mixed water, so different kind of a glycol combination and so on, for taking care of different ambient condition. Yes.
Very good. And what about maintenance? Cooling towers are obviously a lot of maintenance there, and cleaning, and having people to come on site to check your chemicals, and a lot of labor and things there. What sort of maintenance are we talking here for this equipment?
I mean, of course, it depends from the, let's say, the material and solution that you design adiabatic, but I can say that we are almost to speak about the maintenance free on adiabatic. So the water treatment is very much limited or neglectable in that respect. And the major maintenance that you do is more, let's say, to clean a little bit along the year, 2 times per year, the pads that are, let's say, collecting some dirty from the ambient. This is the most or the major maintenance they have to do on a year basis. So neglectable in terms of money and people involved in that respect.
Brilliant, thank you. We did have a question there from Danielle, and it's been answered by Roger, relating to using the technology for data centers and the potential savings to that one. And certainly Roger said there is installation in ANZ data center in Melbourne. So maybe Roger, hopefully you can connect Danielle with that one and give some more information on that one would be good, I'm sure. Very good. Thanks, Roger. So if I'm hearing you correctly, I mean, it sounds like a great way where you can have this choice between saving water or saving energy. If you really want to maximize the saving of energy, you'll use the adiabatic mode or the spray nozzle mode. Whereas if you want to minimize the amount of water you use, maybe potentially use a little bit more energy, you don't use those modes as well. So this sounds like a fantastic option there. And certainly within the context of renewable energy and variable renewable energy, and you may not know there in Italy, but Australia is has one of the highest amounts of renewable energy with rooftop solar and what have you in the world now. And so this is putting a lot of demands on issues with soaking up and adjusting to a variable electricity supply. So this sounds like a really good opportunity to be able to match demand and what's happening with electricity there as well. I'm not sure if you've got automated controls for that one yet, but maybe that's something that we could be considered for local development with Chudleigh, Sutch or something. Good.
Yeah, sure. And what we can say from our side at Diabatic cooler we provide is always we develop a mission control system which integrate into the machine and control in relation to temperature or ambient temperature, how the machine, how the, let's say, the adiabatic should work in order to keep the design condition required. So living water temperature or cooling capacity at the constant level. So the mission control is the critical, is the key of the system. So to make sure that you adapt and you switch from energy to water according to the need. Yeah.
Fantastic. I'll just leave you this one comment there was that A2EP has been doing a lot of studies on electrification of process heating and of course cooling, and one of the major barriers to implementation of things like getting off natural gas boilers and using heat pump type solutions is often the space required to say potentially to reject the cold. And a lot of commercial buildings are very limited with space, and by potentially removing the cooling tower and putting in a solution like this, it could be a case of killing 2 birds with 1 stone. So that's great. Really appreciate the presentation today, and we'll be very keen to see some of those installation references for this sort of heat pump option as that comes up for you. So thank you so much for that. And then for Danielle, who gave that question, I suggested Roger's contact details there on the screen, and might be a great idea just to drop Roger a quick email. I'm sure he'll get back to you with some more details on that data center there for you. Great. Otherwise, Gyula, Masmiano and Roger, many thanks for your presentation. We'll now move on to our final speaker for the day. We do have Kelvin Bradnam joining us. Kelvin is the commercial director for ChemClean, and Kelvin is a very experienced general manager and commercial manager, and is joined ChemClean and who have got a fantastic technology. Now talking about not just reducing, say, water consumption. This is more like now we're looking at actually the chemical recovery to reduce that water and energy consumption as well. Kelvin, over to you.
You hear me okay?
Yeah, we got you.
Perfect. Thank you, Jarrod. Appreciate that. Very nice intro. I'll pay you later. So thank you. I just wanted to say hello to everyone, and especially Jarrod and the team for organising today. So it's a great opportunity to look at different technologies. Jarrod actually saw some of the content I'll share with you today around chemical recovery at a recent Dairy Australia Dairy Manufacturers Sustainability Council event. And we connected afterwards, and he thought some of the content will be relevant here today. And I also see that Ian from Dairy Australia is here, so hello, Ian. So ChemClean has been in operation for 10 years, and they've got successful installations operating across Australia within the food industry. Today, I'd like to take you through what we do and introduce how the associated energy savings are achieved. To be transparent, our chemical recovery system has historically been successful based on the chemical recoveries, which also support wastewater authority and EPA compliance. However, as I'm sure you will all appreciate for being on this call especially, we are now finding that the environmental and sustainability benefits associated with chemical recovery are becoming more and more and as important to our customers. So you heard earlier from Brad and Schneider Electric how their solution can help you identify and optimize chemical and water usage in CIP processes. Now, hopefully I'll show you how the ChemClean chemical reduction system will help you reduce that chemical and water usage materially further. So let's have a look at what we do to achieve that. So ChemClean chemical recovery, it's an engineering solution with IP technology and data and code delivered through a deep knowledge of food and beverage production from a broad stakeholder group. We intervene and direct the waste effluent from CIP wash cycles and clean and return those chemicals back for future washes. So the recovery levels can be significant, delivering an average of 80% recycled caustic and acid. These costs are material, together with other savings, which I'll share with you now. An average size plant, the example I'm giving today is a milk UHT plant in northern Victoria, Australia, which is processing around 300 million litres of milk every year. That would be a medium scale production facility. And that saves around 1.5 million AUD, Aussie dollars, I can't do all the conversions, per year in just chemical usage alone. Then there are further savings in energy, water, other treatment, dosing chemicals, and of course, preventing compliance fines and the ability to potentially maximize your production capacity where potentially limits and restrictions are put on you by authorities. So now I just wanted to let you have a look at some of the potential energy savings this process can support. And as I say, this is a fairly formative view of getting really into the detail, which we're working with customers currently to identify the energy and carbon savings. So using the example I highlighted, I'll just bring that up now, earlier, here are some of their performance results. So this facility consumed 1,000 tonnes of caustic and acid and 500 tonnes, of acid every year during their CIP process. They consumed 2,000 megalitres of water and over 3,000 gigajoules of energy to heat that water in CIP. Now, the introduction of the chemical recovery system from ChemClean reduced that chemical usage, as I said, by 80%. That's 1,200 tonnes of chemicals every year. And about a third of water, 700 megalitres, and 3/4 of the energy required to heat that water previously through those CIP cycles. So with the introduction of ChemClean chemicals, chemical reduction, we just talked about reductions. There's a further 750 tonnes of sodium hydroxide. And the calculation there is that equates to 450 tonnes of CO2. And I'll just give some figures there based on those carbon credits that will be associated with that. Now, there's further benefits for energy through the fact that we know there's reductions from the use or lack of or less use of the boiler. and the production associated with the caustic and the acid, together with the primary and secondary transport into the chemical provider and through into the customer. Relevant for water compliance with your water authorities is a material reduction in sodium, and also the polymer chemical use through your DAF for wastewater treatment. So I just wanted to, I would just say, using the example highlighted, I'm now going to talk to what that means for potential next steps. And as I mentioned, our expertise has been primarily the engineering and technology solution. However, we are building more and more knowledge of the environmental benefits that we're also delivering. We know where energy will be being reduced, and we are now building those calculations of these in the data sets that we've discussed with customers through their CSR strategies and commitments. So we know that diluted recycled chemical retained at 45 to 55 degrees saves the need to reheat potable water. And we know that recycled water reduces the need to pump potable water around the circuits, together with the reduced wash cycles required. We believe we can actually save about 1.5 of the 5 wash cycles, so material water saving as well. And we know that recycled chemicals reduces the production requirement and the transportation requirement of the that would be associated with replacing those dumped chemicals. But we do recognise this can be quite a technical area. I've certainly found that. So we're definitely open and willing to partner with potential and existing customers to build robust and aligned data points specific to energy, carbon emissions, and whatever metrics that you or your company has in your commitments to CSR. So in summary, the ChemClean chemical recovery system delivers strong financial returns, but also material environmental benefits also. We've got 10 years experience working in the food industry and are associated with large engineering and technology providers also. So we're very nimble and flexible in those solutions. I did hear a question earlier about ROI. At ChemClean, we offer varying financial models to suit our customers' needs, whether that's capital, lease, whether it's a lease purchase, or even a tolling option. They all deliver either high IRRs or immediate positive cash flows. So if you do have any interest, or you believe anybody in your organisation has interest regarding potential energy savings, or you feel this solution could benefit your business in any of the aspects covered, please don't hesitate to contact me. Thank you.
Colin, many thanks for that presentation. Very good. And you've got that site there at Shepparton, and I just wondering, did you say how many years that one's been in operation there?
That one's been in operation for around 4 to 5 years. Okay.
And so plenty of data on how that's performing.
Yes, yes. Yeah. That's an enhancement we're looking at now is 4G data that we can see live. At the moment, we sort of get email transactions emailed to us. Sometimes it gives us a delay in seeing where users aren't optimizing that chemical recovery, and we can lose a few days production at the moment through interfacing with engineers. Obviously, if we have 4G, then we'll be able to see that immediately and react more effectively.
Very good. And obviously now thinking about that connectivity, we think about Schneider. Brad, can you just loop that into your CIP optimizer system? No worries.
Of course.
We should have talking later.
Good one. And Kelvin, I think this presentation from you today can be seen as a little bit different to a standard energy efficiency type of presentation, because you've actually got to invest in a bit of equipment, and you've actually got to use a bit of electricity to save that energy as well, no doubt with pumping and what have you. But as we're certainly seeing, we're hearing from various manufacturers, the pressure on Scope 3 emissions and being able to track those and being able to be sure about these Scope 3 emissions. I think what you're offering there is a solution to say, well, take control of your Scope 3 emissions and reduce them for them. And I can also share with you, things like caustic soda production. Part of that can be easily reduced in the carbon emissions in the electrolysis cells, but at other parts whether you need to evaporate that caustic soda, that's not easily so easily electrified. It can be. And also transport. I mean, there's a lot of emissions here with just transporting caustic soda around the world. So you're certainly providing a solution for that as well.
Yeah, we've certainly found that ourselves and our customers historically have focused on those sort of scope 1 and 2s, and there's benefits there that are tangible in energy and water and chemical savings, obviously. But I think the evolution of that now is to extend that into scope 3 so that we can work with customers on their broader commitments internally and to their markets and consumers.
Excellent. And so you've got the solutions with dairy. Any other sort of target areas that you may be looking at?
Yeah, look, it can apply across the board. I mean, not all industries are using the chemicals. So the first question I ask is are you able to see and share your chemical usage? There's a certain scale required at the moment to achieve that ROI, because it is fairly expensive capital employment. But we are looking at more modular solutions for smaller food producers. As I say, not every industry even has CIP. Food industry has CIP, but where there is CIP and where there is high fouling, so that's where dairy does suit that well. But so does brewing, so does winemaking, and other areas, like if you think about the extension of dairy into chocolate, etc. Then there's a number of categories within food and beverage that are relevant. And beyond food and beverage, we also find there's a lot of caustic used in packaging, in paper, and especially in alumina and mining, etc. So they're areas that we've got out of scope currently. We're focused on food and beverage, but certainly the vision for the future.
Brilliant, thank you. And we've got a question there come through, and we've still got a bit of time, so if others would like to put some questions in, please do. The capital cost, that one we saw at Shepparton, have you got a bit of a rough magnitude of the cost there so people could think about that?
Yeah, look, I'll probably answer in relative semantics, but we are talking millions of dollars. And I think one of the reasons I wouldn't put a hard number to it is they are bespoke solutions. We do find if we were part of the greenfield or the CIP implementation stage, then we can be part of that planning process. And we do partner with CIP providers to be part of that conversation, because then if as we have found that we're an afterthought, then we come to an existing site and finding the space and the pipe work and the gantries, etc., and requirements, and tapping into the MCCs, that can all add cost. And together with that, I mean, who can tell what cost anything is today with the availability and the inflation that's coming our way? But we're currently quoting for a job, and we're finding that's a bit of a pin the tail in the donkey at the moment, just to get quotes and availability and current costs that we can tie ourselves to. But we are achieving that, but it's taking a bit more work, as I'm sure we're all finding, to understand the impacts of cost over the next month, let alone year.
Very good. Kelvin, many thanks for that.
Thank you.
Okay. Let me just see if we've got a few slides to wrap things up now. There is a publication available for those that are wanting a little bit more reading. This one here from the Institute of Sustainable Futures at UTS in Sydney. And so if you look for the water energy nexus, there's a nice piece of that one. Quite a strong focus on wastewater and the amount of energy used in wastewater. I can recommend that presentation for you. I mentioned before that we haven't been sitting on our hands, a little bit quiet with webinars in the last few months, but this is one of the publications that we have been working on, and this runs through the sharing of all the lessons learned that we have from running the arena process heating studies. That really distills about 20 or so pre-feasibility studies and the lessons there down into one document, into all the learnings that we have there. So this one is available. If you go to the website futureheat.info, you'll see that you'll find that publication there. Coming up, we've got a few more webinars in the planning. Towards the end of May, we're targeting the 24th of May. We're going to be taking a look at energy recovery, and that can be the case of as simple as heat exchangers for heat recovery, or actually taking some waste heat and turning that into electricity, say by using an organic Rankine cycle type of device. So we're going to take a look at that at the end of May, and then through June we're planning to have some heat pump webinars, looking at just a bit of an introduction on standard heat pumps and the application and the designing of them and sizing, and then having a deep dive into some applications where they can be used. In terms of a save the date, 18th to 19th of October this year, we have our Innovation Exchange annual 2-day conference. We'll have some fantastic speakers lined up, and back to some face-to-face and also some international speakers coming in to join us there. You'll be able to register at those events, going to a2ep.org.au and going to events from there. And so that just about wraps it up. If you do want more from A2EP, you can follow us on LinkedIn. We've got much more regular posts and interactions there, or you can go to our website and register for our monthly newsletter and different advice. So that's it for the webinar. I'd like to thank our speakers today. We had from Schneider Electric, Alfa, Laval, Frigel and Chudleigh Sutch, as well as Chem Clean. Many thanks to our speakers. You'll have their contacts there in the recording that is sent out next week. So feel free absolutely to reach out to them individually. But I think that'll do us for today. Many thanks for joining us, and we look forward to seeing you at our next webinar. Thank you all.